Okay, we're still on page 18. Let's look at C. C is going to be a little bit different because we have a stretch factor in this one. So to label my transformations, start with my shift of my vertex. So I have a +4. That means I'm going to shift left 4. Your horizontal shift is the opposite of what you expect. That's why we're going left. I have a -3 for my vertical shift, so I go down 3. Your vertical shift is what you expect in terms of plus or minus. All right? Is it inverted or flipped over the x-axis? Yes, it is. So how about we just write flip over x-axis? If you want to write invert, that's fine. Again, flipping it over the x-axis just means that it is upside down or inverted. And our last one is we have a stretch. Oh, we're running out of colors. So we have a stretch here of a 3. So we have a vertical stretch by a factor of 3. So I'm going to write stretch by 3. Cool. The order that you do these transformations in is important in order to be able to graph it. We got to start by plotting our vertex because that's like our starting point. So I'm going to apply the first 2 transformations first. I start at the origin. I need to go left 4, and then I come down 3. There's going to be my vertex right there. I know that I'm going to be opening up downwards. And now I'm stretching by 3. So I take whatever my vertical change between points would be, I'm going to multiply it by 3. Starting at my vertex, instead of coming right 1 and down 1, I'm going to come right 1 and down 3. Right? And instead of coming right 2 and down 4, I'm going to come right 2 and down 12. Because 3 times 4 is 12. You're right, we're going to go off of the graph. 2. So I start here, let's see, 2, 4, 6, 7 to the bottom of the graph, 8, 9, 10, 11, 12 would be right about there. Cool. I know that these are all going to be reflected over this line because that's the vertical line that my vertex is on. We call that our line of symmetry. In this case, that's at the line x equals 4. So I just fill in the reflections, and I'm done. That's an ugly graph, but my smartboard's all messed up right now. So this is the graph of our function up here. Can you see how it is vertically stretched, right? The standard shape is a classic parabola like this, but ours is stretched to be more elongated vertically. With me? And our last one over here, we're going to see this one actually has a vertical compression. But let's start with our shift to the vertex. I got a -2. That means I'm going to shift right 2. Your horizontal shift is the opposite of what you expect. I got a vertical shift of +4. That means I go up 4. Your vertical shift is what you expect. Do I have a negative out in front to reflect it? No. So I don't have that transformation, but I do have a 1/2 out in front of my parentheses. That means I'm going to compress by 1/2. Okay? So starting with my vertex at 0, 0 would be my starting point, but I need to come right 2 and up 4. Boom. I know I'm going to be opening upwards because I don't have a negative sign out in front. instead of coming right 1 and up 1, I'm going to multiply my vertical change by 1/2. So I come right 1 and up 1/2, right? Oh. Right 1, up 1/2. Instead of coming right 2 and up 4, I come right 2 and up 2. And then I reflect it over my line of reflection. So,
right 1 up 2?
No, it'll be right 1 up 1/2.
Yeah,
and then right 2 up 2. Because we typically would go right 2 up 4, right? So we multiply 4 by 1/2, we get 2.
Wait. So where does it go? If you were going to the right, how many times for the second one? Twice.
Yep, I come right 2, and then I go up 2.
Oh, from the original one?
Yeah. All right, going left, it's going to be left 1 and up 1/2, and left 2 and up 2. All right, and I can see that my shape has been compressed. If this is my normal parabola shape, this one for me is kind of like this. So it's been compressed because this is a fraction out in front.